Hello, everyone. We are going to see a project in this particular video, right? So, which may help you to get or go through with this video, and then if you go through with the project or if you execute the project, right, you may able to understand what we are trying to achieve here in an end-to-end way of executing the project. So this project is more of like credit card defaulters and insurance premium batch project. We are going to execute this project using the batch components, whatever has been learned in the first part of our learning journey, uh, in which like we are going to use specifically Linux commands, Linux shell scripts, and then Hadoop commands, uh, Python program, and then Sqoop for data ingestion, Hive for doing some sort of SQL analysis, and then HBase and Phoenix for providing some in-memory layer for performing some sort of real-time aggregation and so on. So this project is mainly meant for connecting or integrating all the components, whatever has been so far learned. And then in the sense like the primary components or the base components, whatever we have learned, this project will help you to integrate all those components and understand in a holistic way. And mainly this project will cover the interview scenarios also if you go through. So several interview questions like how do you convert tables from managed to external, or how do we remove some header trailers or footers from the data set, or how do we get the data from the source system, right? All these questions may be resolved in this project actually. So let's go and do a deep dive on this project and try to understand what you're going to get out of it. Okay, so let's go into it. Okay, sorry, I got some audio issue. Okay, so let's proceed further. Okay, so this project synopsis I have just explained here, providing the information about, okay, we are going to get the data from the financial institutions, such as insurance and banking data we are going to collect, right, in this project, where we are going to identify the credit card defaulters list from the banking system, and the insurance premium what the credit card defaulters are about to pay or non-defaulters are about to pay. So since the banking and insurance systems are falling under the financial category or BFSI, right? BFSI category, banking and financial institution systems. So every banks mostly has their insurance department and credit card department, right? So they wanted to relate their own customers to understand who are all the credit card defaulters or who are all the late payers, may have a chance for paying the insurance premium also in a delayed fashion. So they are doing some sort of analysis in that aspect, and in this project particularly they are deriving some sort of KPIs, key performance indicators, and they're trying to understand or generate some reports or insights about their customer behaviors and preferences and all. According to that, they are going to maybe like define the pricing for the customer, kind of dynamic pricing, or they are going to define some sort of, or they are going to provide some promotion or charges they are going to incur for the customer based on the behaviors or based on the transaction what the customers are doing. So this is a complete data lake building project, okay, where we will be having the data, the raw data stored into the Hadoop file system, and then the data will be moved to Hive for different layer storage purpose, like ETL or ELT operated data will be stored into the Hive data store, and whichever the data that requires some real-time aggregation or requires some in-memory maybe like in-memory computation, there we'll go and store the data into HBase, and Sqoop is the tool what we use for pulling the data from some of the data from the DB sources. Even we may do some sort of I mean secure file transfer or secure copy activities from the cloud or any other source systems. Maybe it could be a Linux file system also. So we may do set of activities like aggregation or filtering or grouping of data using Hive in a batch mode, and for a sort of real-time data aggregation or reporting, we use HBase and Phoenix for performing the activity. So this is the crisp synopsis about this project what you are going to execute. So you can go through with the synopsis which has the information about what we are going to ultimately get out of this project. Okay, so we are going to get the data from credit card defaulters information and insurance premium payment information, and we are going to join this data and produce some sort of result out of it. And we are going to get some dimension data related to the state and all, right, the state code and the state description we may be getting. So we are going to do some sort of enrichment of this data also. Okay, let me go into the architecture, right? This is the kind of a technical architecture what we have created, right? So out of which you can see the data ingestion is happening through the source providers for this whole project is going to be a database, or it's going to be the cloud source. So if you consider the database, we are going to get the data of the central time zone and the Pacific time zone data, which is going to be stored in the RDBMS of the source system. Maybe the credit card information of the customer, which is generated in the central time zone or Pacific time zone data, are being stored in the RDBMS table, including which we have the customer information also, the master customer information. These two data sets we are going to get from the database source. And we are going to use, as usual, the Sqoop import for pulling the data into Hadoop. And parallelly, we are going to pull the data, some of the data into HDFS file system, and some of the data we are going to directly pull it into the HBase system, like more related to customer master data we are going to pull. So this is what the primary activity what we are going to do. Then in terms of the other source system, we are having some data which is more related to the insurance data set of the customers, which is being managed by a different team, actually the insurance management team, where they are going to store the data into Amazon S3, the simple storage service provided by the Amazon cloud platform, right? However, if we haven't learned this yet, we'll be learning it in a later point of time. But however, we are using this as a kind of a sourcing layer, where again we are going to pull this data using some SCP or SFTP protocol or wget methodology we are going to use, and pull the data into the edge node. That is nothing but our data ingestion or a gateway or an edge node of our Hadoop cluster. So which is nothing but our client node, where we are going to pull this data by running some shell script. So that shell script is going to further validate the data whatever we pulled from the cloud. And if the data is proper, it is going to store the data into Hadoop again. So this is a set of activity what we are going to do in terms of ingestion. After we inject the data into Hadoop file system, we are going to segregate, or we are going to perform some sort of activities on the data. And some of the data which has been applied with some transformation or some segregation will be moved to some other Hadoop cluster for development purpose or for testing purpose. For example, this is a production cluster. Let's assume we are going to get the data into. We want to move this production data into a non-prod cluster, where it may be running, or this cluster might be a different Hadoop cluster, which may require some sort of data. So how do we push the data from one Hadoop cluster to another Hadoop cluster? You are going to use some tool called distcp, distributed copy. So all these are going to address your interview questions, or even the holistic requirement of how and all we can have the data management or data movement happens. So further to that, once the data is loaded into the HDFS file system using Sqoop and using the using the shell script and all, which pull the data into HDFS, we may apply some sort of transformation logic to identify the defaulters or non-defaulters. And we are going to store that into the Hive tables, right? And where we may apply some sort of overlap queries. The customers may apply any sort of query. If you see this arrow particularly, right, you can able to see the customer can apply any sort of batch or interactive overlap reports on top of the data, whatever we are finally storing into the Hive table. And we are not stopping the data or generation of data only into the Hive. We are going to pull some of the data that we discuss more in detail in a later point of time. This is a technical architecture. So some of the data that we are going to pull from Hive into HBase, that means we are going to load the data into HBase using Hive. We use the methodology called Hive HBase storage handler mechanism. So this is going to make you understand, okay, the Hive and HBase can be interacted. And further to that, whatever the customer segmentation we are doing, actually, like we are going to identify the middle grade, middle age grade, or lower age grade, or higher age grade customers. and we are going to store those data into the RDBMS platform, where the end users or the legacy systems may be going and pulling these kind of whatever the computer data in the big data platform can be queried by the legacy system also parallelly. So we are enabling data in Hive for analysis. We are enabling the data into RDBMS platform somewhere else. Maybe this is not the Hadoop cluster. Maybe this image is misleading. Actually speaking, this is more of this database is running in yeah, maybe like out of the Hadoop platform. So we are going to do a Sqoop export of the data which is produced by Hive, right? As a kind of an export, we have produced this data. This data is going to be exported into the Sqoop, into the some other RDBMS, which contains some middle-aged customers, which whose data is getting masked actually. So this data also might be produced to the end users, where they can apply some legacy SQL queries to pull the data from this RDBMS directly. And we are not stopping pushing the data into RDBMS. We are again take this data and performing a kind of a Sqoop import into HBase also, with all this data, whatever the mask data we have. Then on top of the HBase data, whatever we pulled using Sqoop import directly from the original source, or whatever the computer data that we have got into the database, that also we pulled into HBase, and whatever the intermediate data that we stored in Hive, that also we stored into HBase. So HBase got the data using Sqoop imports and HBase, Hive HBase handler also. This data set in HBase, we are going to do some sort of low latency processing queries, right? On which we are going to apply some sort of real-time aggregation for performing some sort of analysis and report actually. So this is all together we are going to achieve in this project by having all the connections maybe managed across the systems. So this project will holistically give you all the knowledge of how the systems can be interacted, how we can pull or push the data across the system. So if you look at here, the data ingestion and acquisition is going to happen through Sqoop from RDBMS into Linux, into Linux file system. I mean, into from RDBMS into Hadoop, and the data is going to be injected into Linux and Hadoop file system using cloud sources. So whatever I discussed earlier, just I have mentioned all of them over here in the points actually. So you go through with these points to understand like how and all or what you are going to do as a holistic view of this whole project. So I'm going to explain in detail about what we are going to achieve here. So data ingestion is going to happen through Sqoop into our Hadoop platform, right? And we are going to do some sort of shell script for injecting the data into our Hadoop platform. These two things we are going to see in this project as a whole, okay? So primarily for data ingestion purpose. So prerequisite, have your VMware started or your VM running with all the components, whatever is mentioned here, right? And for your better clarity, we have mentioned with the legend actually. So blue color represents just the description saying like, okay, why we are doing this or that, all the stuffs. Red color represents some of the key points what you have to consider. And the brown color represents more of like what is the activity that you have to execute. For example, you have to write the code, or you have to write the scripts, or you have to develop some SQL queries. Or for example, if we take here, we are going to set our VMware memory. For example, if you have around 4 GB of RAM, make it as 3 GB, right? You have overall computer with your machine with 4 GB RAM. Go and make your VMware 3 GB. Or if you have 8 GB of RAM, you can make it as 6 GB. If you have 12 GB, make it as 8 GB or 10 GB like this. You can allocate only 1 or maximum 2 GB for your Windows layer, and the balance RAM you can allocate in your VM completely, okay? So you can go to your VM and you can see here in the manage virtual machine settings, right? You can see the RAM, how much I have allocated around 14 GB, 14 plus GB of RAM, because overall I have 16 GB RAM. But you ensure based on your capacity, whatever you have, you can allocate your RAM capacity. Okay, so this is all the prerequisite what you have to do. Go and follow the strategy what we are providing. Okay, so the thing is, what I have did over here, I just provided you a tar file in the G drive location or somewhere, right? So what you have to do, how I created this tar file first of all. So after I tested the project by having all the scripts and everything ready, right? If you look at here, I just created this tar file. So if you look at this, this is the folder where I have all the code actually, including the Python script or shell script or the data set and everything, including the Hive queries and all the stuffs I kept over here in this particular folder. If you just look at this, right? So what I wanted to do here, this folder I wanted to provide you guys by creating it as a tar file. This folder I don't want it to upload in the G drive. I want to make it as a tar file, and the tar file has to be compressed and I have to provide it to you guys. Okay, so for that what I'm going to do is I'm just simply going to perform tar CVF, right? Which represents what? I'm creating the tar file. I'm not extracting. I'm creating a tar file in the name of credit card insurance dot tar. So I'm creating a tar file from this folder, whatever we have. So this folder I'm going to mention. So this folder will be converted into a tar file now. You can see here, all the content in this folder are getting tarred. Tarred means it is getting created as a package. So if you go and look at this folder, this particular location, when I perform this activity, you can see there is a tar file got created here. What I'm going to do, I'm going to zip this tar file. So this file become a zipped file now. You can see the zipped file that I got. So this is the file I'm going to upload in the online, maybe in the G drive or wherever. You guys are going to get this downloaded into your VM. Into your home directory, you are going to get this downloaded and you are going to untar it. Since it is in a zipped file format and in a tarred file format, whatever I created and I'm providing to you, you are going to extract this tar file, which is already compressed. So you are using Z option. So it is going to uncompress, it is going to untar, and it is going to provide you a folder called credit card underscore insurance folder. So you are going to see a folder like this in your environment now. This is the folder where you have every programs and data set and everything available. So you don't have to worry on anything. Just you can start work on this particular project. So if you look at here, I have provided you two PDFs. Even this PDF has been provided in the outside of the, it's openly provided initially also. And inside this project also, I have provided this PDF. So one without solution and another one is with solution. What I would request you to do, first you go with the file called without solution, as like how I'm doing. Then you can go and open and see the with solution. If you want to see some solution here and there, for example, if you look at this, I have provided the Sqoop command here. Okay, but in this particular whatever the without solution document, if you see, I might not have given everything for you. I have given only some create table statement and other stuffs and all to help you doing this exercise faster, rather than you sit and type all this. It's a time consuming process. But however, the Sqoop import or anything else that I wanted to perform by you, I haven't provided you as a solution. I just mentioned saying like provide your solution here. So you try provide your solution. If it is taking too much of time, you can go and refer the equivalent document which contains the solution, right? You can see here. This is the solution for whatever that I have typed over there. So either you can go and get this information and understand and do also. If you want some detailed information or if you could not even understand what I mentioned here in this plain text, right? You can just refer that solution document also. I'm not going to stop you. Whichever the way you want, you can try to execute this project. Okay, fine. Let's go inside it, right? So you got this tar file untarred and you are going to see all the programs or data or scripts or anything else, right? It will be kept in this location. Okay, ensure you have all your daemons are running. If you want to quickly get some of the commands and all to start the daemons, if you haven't started, make use of these commands, whatever I given for your purpose. Okay. So first time you guys are going to create, you are going to log in into MySQL and you are going to create some tables. So this will be usually happening automatically by the source system. You are not going to do this work of creation of this data and all. But however, For our project purpose, you are going to drop the tables if already exist. You are going to create some table called credits, PST and CST's time zones, credit card tables. You are creating and you are just adding or loading some data from the location wherever I have this data available. So 2_2 credit card default test.pst file is already there in this location. If you look at this, so you don't have to worry of doing anything. All the data I have already provided in this location. Your work is to just make use of this. You can see this files and all contain set of credit card defaulters information. So your work is to just make use of this, right? You can see here all are having as an insert statement. So just try to execute the source command in the MySQL environment. It is going to run this particular script and get all the data loaded into the respective tables like credit CST or credits PST and the customer master. You have some customer master data also. Everything I created as a insert statement. Your work is to just insert and get this data loaded. Okay. Now, what you are going to do further is whatever I just removed, it's just for your reference. Okay, you just don't have to execute this. You just refer this if you have any need for this. So now we are going to perform something Sqoop integration with Hive plus ETL and ELT operations we are going to perform. So what we wanted to do is merge the two data sets using Hive and split the defaulters and non-defaulters into two data sets and load it into HDFS. This is what my requirement. Simply I may ask like this: merge these two data sets using Hive. But what you can do, you can first pull the data using Sqoop into a Hive table, right? And then what you have to do, so you are first going to create one table, database called Insurnce or Insure in your Hive side. You are going to import the data into the Hive table directly, right? With the table name called insure.creditspst in Hive and the credits CST in Hive. Using the Hive override option with the number of mappers 2 or all these features, whatever I mentioned. One noticeable feature, what I have mentioned here is in the source database side, it is ID, which contains integer type, but I'm going to make it in Hive as begin. So you are not going to create the table in Hive. Rather, at the time of Sqoop import itself, you are going to use some option called map column Hive option, which can help you to set the data type for certain columns actually. If you want to understand about this map column Hive, we'll go and search online or cookbook or the project solution document also, which explains about what is this. So I am going to say, hey, do all the activity, directly load the data into the Hive table, but the ID column is not supposed to be created as integer in Hive. It has to be begin. And the bill amount should not be automatically created as integer type. It has to be float type. Like this, I am mentioning some explicit type to be created in the Hive table, because basically Sqoop will create the Hive table in this case actually, but Sqoop will go and follow the same whatever the data type this credit CST or PST table contains. If you consider the credit CST or PST contains integer type, but I want to create it as a begin in Hive, so you can use the option, right, which is nothing but map column Hive option to create the respective data type whatever you want. So you try to provide your solution here by executing the option and all how you are going to execute. Okay. Let it be. You can refer the document or online or get it done. Then we are going to perform ETL and ELT operation using Hive. So you got the data into the Hive table now. What I wanted is filter the CST and PST tables with bill amount greater than 0. So filter only the data that has bill amount greater than 0 and union both the data set and load it into a single table called Insurnce CST PST order, because we earlier imported the data, all the data into two different tables. Now I wanted you to import this data into one table. That means not import. I wanted you to merge these two data sets from the two Hive tables, whatever we created above, into another table called CST PST order using CTAS. That means I wanted you to perform as create table as select on top of it. So try to do that and provide your solution here. How do you go and perform union or filter and all the stuffs in Hive? So you are performing some ETL operation here, extracting from the Hive tables and loading into another Hive table by applying some transformation called bill amount greater than 0 and whatever the union operation you are performing as well. Okay. The above step you can perform, right? The step number 2 and 3, you can make it happen in the Sqoop itself, because you are going to pull the data from the database source without having these two intermediate tables you created. You can avoid the step number 2 and 3 for creating the intermediate table our Sqoop import by creating the two intermediate table and performing CTAS to create the final table. You can directly create this final table and get your data loaded into this by using the Sqoop import itself, right? By writing some query option actually. So if you want, you can try it out also, not a big deal. Okay, so you can try this. Otherwise, what we can do, this fourth step is optional actually. If you want, you can try. This is an alternative for step number 2 and 3. Okay, fine. Create another table, right? External table of type external table, right? Insure.cstpst penalty in ORC file format, right? You can use the show create table option of the above table, whatever we created here in the step number 3, to get the DDL, and you can modify by adding some ORC file format or whatever you want and make it as external table and all. So you don't have to sit and type all these commands. But however, I gave this query for creating this table also very simply. You guys can make use of this. Don't have to sit and type, spending a lot of time. Okay, just do this, and then what are all the activities I have to do? You have to do. So I want you to apply some calculation like this. Apply some case statement to calculate the limit of the new limit for the customer that I want to provide for the credit card. So what I'm going to do is I'm going to reduce the limit provided to the customer for about 4%, right? Because they have performed some defaulting, in the sense they are going to they did some defaulting. So I'm reducing the limit provided to this kind of customer in a going forward fashion. If they default it again and again, therefore 4 or 5% of their overall limit, credit limit, will be reduced each and every time. So that's what I'm doing here, and I'm capturing other information. I'm increasing the bill charge also. If they did some sort of defaulting activities of not paying the payment properly, right? I'm going to charge them some amount actually in their bill actually. So they are going to get a new bill amount and they have to pay the penalty also in addition to that. So provide your solution here by performing this query, and go through with our maybe the solution document to understand what is the equivalent query that I have created here. So you are going to perform insert into this data into a table called CSTPST penalty table. So what you have to do is you just pick all this data and insert into the above table what we have created. Okay, that's what I wanted you to do in this step number A. Step number B is what? Export and override the above data into a location that is default as out or whatever it may be. We'll be using the default as out data in a later point of time. So I wanted you to export and apply the overwrite option and store this data whatever we loaded right into this location in HDFS. And non-defaulters data also I wanted you to export into this Hadoop location by using Hive. So how do you do export of data into Hive? I mean into a Hadoop location using Hive, you guys have to apply here with the comma delimiter by applying the filter of defaulter equal to 1 and defaulter equal to 0. Defaulter equal to 1, you separately run as a insert override directory like those options in Hive you use, right? You try to use that. Then we will be using this defaulters data or non-defaulters data in a later point of time for performing some sort of activity. Okay. So the non-defaulters data we are going to send to the other system using DistCP or SFTP protocol. We are going to send this. Okay, let us see this in a later point of time. So provide your solution. How do we do an export of data from Hive to a HDFS location? That's what I wanted you to do here. So data provisioning and consuming using DistCP. So copy the non-defaulters data, whatever I mentioned in the above step, right? From your production cluster to the non-production cluster. So you segregated only the non-defaulters data from your Hive table, right? That data alone you are going to take out, and you are already you have taken out, right, in the above step, whatever the non-defaulters data in this location. I wanted you to copy this data from this Hadoop location to a different Hadoop location of a different cluster. Maybe since we have only one cluster running here, I wanted you to copy within the same cluster itself, but using maybe DistCP, right? Not using the normal copy command, because the volume of data is going to be really high. So copy will take longer time. DistCP will be faster. So we got some data from the database and pushed it into the Hive table, and we segregated the data, applied some transformation logic, and the transformed data or segregated data are being stored into Hadoop file system in a different cluster, and we are having the default as data still in the Hadoop location. We are going to use it for a further purpose. Now we are going to inject some more data from the different source system. We so far injected only the database data into our Hadoop platform. So what data we are going to inject from the different source system? So we can assume this as a cloud source or any other file system source. It's not always supposed to be a cloud source, but let's assume in our case, we are going to pull the data from the cloud system like AWS system. Okay. So you are going to have this shell script developed, or you can refer the shell script, whatever I mentioned in the project location. You guys can go and open the shell script and find what I have just did over here. Okay. Is SFM ensure data.sh is the shell script created, where we go and pull the data from the cloud location, wherever I just kept some sample data over there. And you are going to get those data into into our Linux location, and we are going to validate the data, whether it contains the trailer and all or not, whether you have the trailer value or not. And then if the trailer value is equal to the actual data value, you are going to maybe do some sort of comparison. If both the trailer value given in the file is not matching with the actual whatever the file count, whatever we have, you are going to reject those data as an invalid data. If the trailer value, whatever the source system have given in the last line of the file, we are going to use some tail command or whatever the R command to identify the value of the trailer count. Actually, I explained about the script earlier to you guys as well, if you remember. However, you go through and try to understand the script more in detail. I don't want to go a deep dive into the script actually. So you are going to remove the trailer value from that file if you find it is matching, and you are by using the sed-i command of $d, which will remove the last line of this particular file, and you are going to move this file into Hadoop file system. So several Hadoop commands we are using here. We are moving this data into the Hadoop file system with a block size of 64 MB. Okay. So you're understanding some sort of Hadoop command over here as well, or recalling the Hadoop commands also, whatever we used. And in addition to that, if the above statement is successfully completed, you are going to create some success file to intimate saying like, hey, this data is properly copied into this location, right? So we are just copying that, and we are compressing this file and archiving this file into some archive location of our Linux file system. And then we are finishing this script. So this script is going to pull the data from the cloud, and it is going to push the data into Hadoop, and the Hadoop location is going to have this data for our further usage. The insurance data, we are going to have it in our Hadoop location. We will use the data in a later point of time all the way down. Okay, you can refer whether the data has been properly imported or not into this Hadoop location by using the above script. But you have to go through with the script thoroughly and understand why we are doing this and all. I thought of asking you to do the script of your own, but however, you guys can consider this as a requirement and try, or you can go through with the script and understand how it works. Then you can try also, maybe whichever is fine. But you get an opportunity to work on this shell script, which will help you to pull the data from some source system, right? That's what I wanted to achieve here. Okay. ETL and ELT operation, again, we are going to do using Hive for this kind of data, whatever the insurance data. So I'm ensuring if the database is not there, I'm creating it. Already it is there, so you don't require this command, but however, I'm ensuring that. So create a table called Insurnce, right? And you are doing what here? Row format delimited fields terminated by comma and you are using. And what I wanted to do here in this table particularly, provide your solution to here to add the property to ignore the header record. So the data, whatever we are receiving from the cloud, the insurance data may have some header, that is the column names. I don't wanted the column names to be added in the data when I just go and import from this location. When I load this data into this table, I should not have the should not have the header value of the column name should be included in the data. So I want to remove that. Hive, I am asking, hey, remove the first record alone. Don't consider the first record, which is a header. How can I do that? Look at the solution, right? You have to use the table properties with the header value as number of header values, whatever you have to just mention that as skip header line count equal to 1. So it will just ignore that header value. So whatever, you just go through and understand what you are supposed to do here. So try to understand the data first, then you try to see why we are applying this transformation or this particular requirement. So there is an interview question asked, hey, I wanted to avoid reading the first line of the file from in a Hive table. How do I do that? Or last line of the file content in the file. in the Hadoop file system in a Hive table. I want to avoid that. How do I do? This is the interview question. You can resolve that by answering this. Or what I would ask you to do, rather than going and creating a direct table like this, I wanted you to go with the partition table node. So I wanted to create this table based on the hourly partition, date and the hour partition. Basically, you guys did not partition the above statement. I wanted you to apply the partition, and each and every partition load has to happen with the removal of the header value. So here I'm saying either or, either go with a normal table or go with the partition table. So partition table will give you more clarity of doing how to do partition and other stuffs. In order to achieve the partitions on the data, whatever we received in the location where cloud have injected, right? What I am going to do is, this is a maybe like a Hadoop location from where I'm going to pull the data. So I think I wrongly mentioned the home HD user location, right? The insurance data, cloud data should be in the user HD user location if you can look here. So I'm going to run a shell script which is going to read the data from this location, and it is going to automatically identify the load command, and it is going to find the file name and the maybe like the pattern of the file also, right? The date and the timestamp he's going to, or however it is going to extract from that particular file name actually. So if you look at here, insurance cloud data, right? If we look at this one, this particular file, oh, sorry, I think this file got removed actually because of the load that I made in the Hive. So if you look at this script actually, right? If you look at this particular script, if you run the script, you can find, so you have, if you run the script, right? So SFM insurance.sh, if I'm going to run like this, by passing this particular location as an argument, it's going to pull the data from the cloud source, and it is going to maybe push it into our whatever the Hadoop location. So actually it is not running for me because of I have the script, the URL and all wrongly given in our particular whatever the script actually. So I had to use this. So for that I had to connect with Putty and do all these activities. If you look at this data is getting imported and it's getting removed with the trailer data and all, because it validated the count with the trailer and without the trailer also. And the actual count it is validating, and it's pushing the data into Hadoop now. So now we have the data in this location, actually speaking. The data copied successfully to HDFS, right? So this is the location where you have the data. What I'm going to do, I'm going to load, I'm going to identify, I'm going to run one more shell script to identify the day of the particular, the date of this particular file and hour of this particular file at 07th hour. You see the date, what it is showing in my server. It is showing 21st of September, right? So you can see 21st of September, you can see the date. And the hour is 7 o'clock, it's showing actually. My server is bit has long older value. Let it be, not a problem. So you are going to load automatically by having a shell script created here. You can look at this shell script again and next shell script. Even you guys have seen this also, right? So this shell script you have to analyze how we have achieved this. Hive part.sh, whatever the shell script we created here. So you have to understand Hive part.sh shell script, which is going to automatically identify this Hadoop file. This is not a Linux file. So you can go through with the shell script to understand what and all we are doing here. So it has to go and read the Hadoop file, right, from this location, whatever I'm passing, and it is going to get the file, the folder name and the date and the hour and all, and it is going to substitute that in this particular partition information and the load command. And whatever the number of files I have in that cloud location, the Hadoop location, whatever we imported, it is going to just put that in the part load script and it is going to execute and load the data into the Hive table. That is what this Hive part script is going to do. So you have to run this Hive part script rather than manually creating and loading the data into this partition table. You have the partition table alone created, but you are going to load using the shell script. So this is the next part I wanted you to try. Maybe if you want to see the solution of after loading the data or running the shell script, right? You don't have to give even the load command, right? You can directly get it done. I wanted you to provide the solution for performing what? Provide your solution creating the shell script even. You don't refer the shell script, you try create the shell script of your own also. That's what I mentioned here. Provide your solution to create a shell script like to achieve what? To go and pull the data from the, so I mean already the pulled data is there in this location, right? What I wanted you is I wanted you to go and identify this data, create a partition statement like this, like load data in path into the table with the partition of column. Partition of column should have date as the file date and the hour as the file hour, and the data has to be loaded into this table called insurance table, right? With the credit card insurance data, which is the file name, the file format. I'm looking for the file format called credit card insurance. If you just look at here. So I'm searching for this credit card insurance, picking this year and hour from this file. How do you pick the year and hour using arc command and all? You have to see, create a shell script to achieve this functionality, right? Otherwise you refer the solution or the script itself and try to understand how it is happening. Ultimately, I wanted this to be done automatically, not by manual intervention. That's what I just noticed here or mentioned here. Okay. Now I want to delete some invalid data with null issuer ID and null issuer ID too. If these IDs are null, I wanted you to delete those records from the Hive table, whatever I got created. How do you do that? So check for how do we perform a delete operation, not by doing a literal delete. You have to do insert override, right? At the partition level. So in this hover, whichever the issuer ID is null or not null and issuer ID 2 is not null, those data alone I'm going to load into this table or overwrite into this table. This table already may have with null values of issuer ID. So I'm going to remove those nulls. You can see considerably some values, number of records get reduced. That I wanted you to try. Then the next iteration, what you're going to do is I have some fixed with data in the location of maybe in the Linux itself. I just provided you this data, the state's data, state code and the state value it contains. I wanted you to create some regular expression SERDI, right? Through which what you can do, you can go and mention, right, how much values I want to read. First two columns or two characters I want to read for state code. Balance 10 characters or 20 characters, I want to read it for state description. Like this you are seeing here. How do we apply this regular expression SERDI? To read the fixed with data, you try to understand. Go through online and try to understand, or even the solution document and try to understand. So we are loading some table called state master or whatever it may be by having the fixed with data loaded. This is the activity what you're performing. Then the third thing, what you're trying to do here, right? So go to insure domain or insure database, create a table called defaulters with all these parameter, all these arguments, what I'm mentioning here. Then you create I mean, just create this table defaulters, right? And on top of the location what we created earlier in the above, in the step number 2 or 3, we created the defaulters output location using Hive, right? That location we are pointing here in this table. So whatever the location we produce the output of the defaulters list, right? That I'm loading into this table by directly creating a table on top of the location where the data contains. Okay. Create one more final managed table. I'm asking you to create it as a managed for now, then later you convert into external. So create a managed table in ORC file format with snappy compression. This is an efficient way of creating the table, right? And load the above two tables joined by applying the different functions as given below. So I wanted you to load these tables, right, by using some sort of specification that I have given in the down. So this table should not allow duplicate also when it is empty, and it's not if not using overwrite option. So the thing is, uh, if this table is empty, right? It should not allow duplicates if the table is not empty, in fact, actually speaking. So if the table contains some data already, again, it should not be allow us to load the data into this table. That's the one thing. Or you should not, if not using overwrite option. So that means the table can be created as an immutable tables. Immutable in the sense it will not allow you to load the data once again. Only once for all it will allow you to load. Or if you use overwrite, it will just delete and load. That is a different story. So in order to avoid duplicate loading of data, we are going to create this table as a something called immutable table. So I wanted to create one table, right, called Insurnce STG. I just mentioned all the table statement over here, and load this data into this Insurnce STG, right, by joining the insurance and the defaulters. Insurance is the one what we long back created, and the defaulters is the one what we just created above. So I wanted you to join these two tables and load the data into one staging table called Insurnce STG, right, by performing some set of activities like identifying the gender of the customer or the age category of the customer. I'm segregating the customers, or this is called customer segmentation, right? Education category based on the education. I'm identifying what level of gender of this customer, or what is the grade of this customer in terms of education, what is the grade of the customer, I'm trying to find the penalty values also by doing this single query. Actually, I'm performing a lot of ETL operation here, and I'm storing the data into some table called Insurnce STG. This Insurnce STG table is getting created or getting loaded with the help of or by joining the insurance table and the defaulters table created above in the above statements actually. So that's what I'm trying to do here. Okay, so let it be. So 1 second. Fine. So you can see here, I'm just going to create another table which should not have the duplicate or provide your solution here to create a ORC table, right? And in addition to that, I want to add the table properties to say this table should be immutable and snappy compressed. So how do we add those properties? So I want you to create another table called insurance ORC. This is going to be your final table. What I'm going to do here is from the staging table, Insurnce STG, I'm going to load the data into this ORC table finally. Why I'm creating staging table? Because I can't directly store the ORC table. I have to go through staging. So I'm creating a staging table and I'm loading the data over there. From there, I'm storing the data into a final ORC table. So how you store the final ORC data? That's what the solution I have given over here. So how do we make the table immutable? That means it should not allow duplicates. Once for all, it should be allowed to load the data. Again, if you try to load the data without using insert overwrite option, it will throw an error. Table is immutable, right? So run this query once. Second time you try, your query will not be successfully completing. It throws error. So that is the property called immutable, and you are going to make the compression as snappy and stored as ORC. Create this table by mentioning the solution. So that you refer the solution document. So ultimately, I want to create a final table called Insurnce ORC, which should be of snappy compression and which should be of immutable in nature and which should be of ORC format. Now you go and finally make this table as external. Convert. So since we created it as a managed table, I wanted this to be external going forward. So what I can do here is alter the table and make it as external. So when we use this property, convert the table from managed to external, if we directly import the data using Sqoop from a database into Hive table, the table can't be external. It can be only managed. So you can use this option, the set properties of external true, in Hive to make the table converted from managed to external. So that option I'm trying here just for your understanding purpose in terms of interview and all, you can clear this. Okay. I'm going with something called common table expression in Hive. What is common table expression? Basically, you can write a from class query. So you can say from of all this select statement you can write, and you can name it as T1. And you can mention something called from of the inner join from of all this whole query you can run and make it as T2. Rather than doing that way, we have an option in Hive. We can create a temporary view, right? By saying with class you can use with T1 as. So that time what I'm saying is load all this data into a table called T1 or into a temporary table called T1 and load all this maximum penalty value for the female customers in a table called T2. Then you join this table T1 and T2 and provide me only the penalty, the maximum penalty for male and maximum penalty for female, where I'm seeing the pivoted data. Okay, I'm calculating the maximum value for the male and female by segregating that separately, and I'm calculating that maximum value and showing. So I don't have to mention the query here. Rather than I can separately create that query first and name it. I'm giving a name for this query. We call it as a common table expression, CTE. Okay. This common table expression is supported in Hive also as like a other traditional databases. Just for your information, I created this. Okay. Now what we are going to do, whatever the data that we got earlier, right, in a table called something called Insurnce ORC, that is the final table we created above. I wanted to expose this data to the development environment or some other environment. I want to send this data to some other system, maybe a database system. What I'm going to do, I'm going to apply some transformation, some masking logic. What I'm going to do here is, I'm going to convert the .com site information and all as .aaa because no one I don't want to expose the .com site URL completely to the customer. So network URL, I'm going to change something A to X or B to Y or C to Z or S to R and .com to .aaa. I gave you some sample here. You can apply any transformation logic here. So I'm using some translate function in Hive to check this network URL value. If it contains A, make it as X. If it contains B, make it as Y. Like this, I'm applying some masking strategy here on the middle-aged customer with the issuer ID is not null. You can either do in the above way what I mentioned, or you can create a masking function using Python, what we already created in our exercise. You can alter that masking function to handle this kind of data, not the transaction data or something we had earlier. So I provided you the script also in the place. If you want, you can refer or you try creating also and try to implement that. That's what I wanted to provide here. So you export the above view data. So what I'm trying to here is trying to create here is a view. So when I run this view going forward, it will implement this transformation logic. Without giving this complex query to the customer, I'm creating it as a view. So I'll say, hey, customer, you will go and run this view. Whoever runs this view, they can't see the actual data. They can see only the masked data. I'm not going to give the access to the sum of the customer, the whole actual table. I may give only the view access. So they can see only the middle grade customer information along with the masked network URL. So that's what the idea here. So you export the view data into a HDFS location using pipe delimiter. You know how to do this. In Hive, how do we export the data with all these columns I wanted you to do. Then all the column that you have exported, I want to take this into a Hive table, into a database table, something like this. Create a table in the MySQL. I wanted to take the exported data, masked data from the HDFS location using Sqoop export into MySQL. And I want to add some option called validate in Sqoop, which will help you to ensure whatever the data that you have exported or imported using Sqoop is being properly happened. You have an option called validate to perform this activity. You just try to explore this and try to add your solution here. In Sqoop, you are learning one more concept called validate. Earlier, how do you learned something called a map Hive column, right? The same way we are learning some more options in Sqoop here. Okay. And I'm going to create a complex data type table in Hive, something namely Insurnce ORC collection or whatever it may be. And I'm going to have a named structure created. That means I'm going to keep all the like data into one column called something like personal info or whatever it may be. and I'm going to put them in a structure fashion. Okay, marital status, the sex and the grade of the customer, I'm going to keep it in a single column called personal info in a structure format. Then I'm going to collect the data in a maybe like in an array type, all the network name whatever the customer have accessed and the network URL whatever the customer have accessed. All of them I'm going to collect in a collection type, and I'm going to have some data pivoted here, and I'm grouping based on the issuer ID named struct of all this column. I'm going to group all the data and hold it in a table called insurance warsic collection. And that table, I'm going to make it as external table further after creating it as a managed. Okay. So this is the set of table I'm going to expose to the outside customers. Okay. Select only insurance issuer ID, how we are going to get some of the data from this table. That means the complex type table, how you are going to query. That is what I mentioned over here. You try execute this query for accessing only this activity by looking into the solution also. Now, I'm going to perform a data migration from database to HBase and using Sqoop and using Hive. I'm going to store the data into HBase also. That's what we are going to do here. Whatever I just removed, we already have did this as a part of the Hive HBase installation and all. So I just added it for your reference. Okay, go to HBase shell, create a table called customer master with a column family called customer, right? And using Sqoop import from database into HBase master data and save the output log into a log file. So what I'm trying to do here is I wanted to execute a Sqoop command to pull the data from a customer database from my MySQL and store the data into HBase, right? And the whatever the Sqoop command that is executed, right? The output of that Sqoop command has to be stored into a log file. So in the log file, I'm going to validate something by checking whether the data is successfully validated or not. This command I'm going to search, or this message I'm going to search, because I mentioned some option called validate in Sqoop. So this validate will help me to put a log in my Sqoop file saying, the log file saying, hey, data successfully validated or not. So if the data is successfully validated, I'm checking for that. If it is successful means, then I'm going to create one success file called HBase success. That means the data has been properly imported from the RDBMS to HBase successfully. By validating this, by doing some script or some command, I'm understanding whether the HBase data, the data is been properly scooped into HBase. That is what I'm trying to achieve here in this particular execution. So I'm going to push the data from RDBMS to HBase using Sqoop. I'm not just only pulling, I'm validating also after the pull is completed whether it is successfully happened or not. This is a shell script what you are creating. We can achieve this using something called Woozy in a later point of time, but however, for now we can try to understand in this way. So data movement or migration from Hive to HBase using storage handler. This you guys have already seen, but what I wanted to do here is I wanted you to create the HBase table in Hive, right, by mentioning how the columns has to be mapped and what is the HBase table. It has to store the data called insurance Hive and so on, right? And this table we are going to load the data in Hive, which is going to in turn load the data into HBase, right? That's what we are going to see here. So just do an insert into this Hive table by performing some sort of operation on the actual data in your ORC table what you created in the top. So this will load the data into HBase by adding some row key, row number of over function you can use for generating some auto-generated key 1, 2, 3, 4 like this for each and every record. That's what we are doing here to perform an operation of loading the data into HBase. Then on Phoenix side, you are going to query this table. For that, what you are going to do, you are going to create a view, not a table. In the name of the same table, whatever you created in HBase, you are going to create a view on Phoenix, okay? And you are going to apply some sort of SQL logic. Here we are going to perform some operation of converting this age value and all into number. And I mean, a two-number function will help you to encode or I mean decode the data in a number format, and I'm going to convert it into an integer type because I want to apply some average calculation or min max or whatever the calculation that I'm going to apply. Okay, so profession wise, level wise, the average age calculation I'm doing here. The same way as level number 2 I'm creating, where I'm aggregating the data in a bit different way. So I'm going to perform an average age. Along with that, I'm going to calculate what else, right? You can see One second. So in the level one, what I'm doing, I'm just grouping the data based on level and profession. In the level two, I'm not grouping the data. I'm directly taking the actual maybe age of the customer, not average age. This is an actual age, actually speaking. The column name is mentioned as average age because the union all requires the column name should be same. Okay. Then the third third query I'm executing with the level number 3, where I'm grouping the data based on profession alone. So what we are trying to do here is we are creating the data grouped based on profession, grouped based on level and profession, and grouped based on maybe no grouping performed on some data. So all the 3 data set which contains different levels of data, different level of aggregation, but I'm storing everything in one single table. That's what I'm trying to do here in this particular query. Maybe I'm doing this query. When you run this query, you can able to understand how and all I'm applying the kind of like what to say the aggregation levels and all. This is what I was talking about, something called cube in databases. Okay, so fine. This project seems to be like we have everything mentioned here and there, and lot of scenarios have been included here and there. Definitely, this is going to make you feel like, hey, what is this? We have a lot of stuff to see. However, if you put an effort, this is a project you guys are going to do maybe in real time by spending months of time, not in 2 days or 3 days. You are going to achieve this in 2 3 days, and if you are able to understand to an extent, means feel happy for that. Okay, so all the best, guys. Try do complete this project ensure what you guys have learned or try to capture that information. Okay, thanks for visiting this or going through with this recording. Thank you all.